Good morning, dear students. We are going to see the next session of wave optics. Okay, optics. We have already seen some of the important discussion about whether the light has both particle nature and wave nature, and how it is behaving like a particle, and what is the particle is called it. The particle is called h nu photon, and how the wave is behaving, how the light is behaving like a wave, how the light is behaving like a particle, everything that we have discussed. And let us go see the continuity of the wave optics. Okay, so next, if you see, the amplitude is the maximum displacement. Now, what are the things that we are going to discuss here is certain characteristics of waves. That is what we are going to discuss it here. Okay, so characteristic of waves that we have already studied in 11th standard also. What about waves, everything that we have studied. Still, as a continuity, we are studying it here also. Amplitude is the maximum displacement of the elements of the medium from their mean position or equilibrium position that we can consider over here. Okay, as you can see here, the amplitude is the maximum displacement of the element medium from their equilibrium position of the waves. As you can see the wave diagram in here. Okay, in this center is called mean position. From here, what is the maximum displacement? Okay, this maximum displacement is called amplitude. Okay, that is why it is called as amplitude of the wave. The second terminology which we are going to study here is phase. Okay, phase of a wave is described as the state of motion as the wave sweeps through the element at a particular position. The position where waves goes over here. For example, the wave, you can see the wave diagram here down. It starts from the mean position and goes negative down, and it goes up. So the position of the wave is considered as the phase, whether it is plus or minus, that we can decide by the behavior of the waves. Next thing we are going to discuss here is wavelength. Okay, wavelength is defined as the maximum distance between two consecutive crests and two consecutive trough. Okay, so this is the wavelength. This is center of the maximum center of the wave. From here, one consecutive crest is over, or one consecutive trough. Between these two, if we consider the distance, this distance is called wavelength. Okay, so next thing is we are going to see about the time period. Okay, time period of the wave. Time period is nothing but the wave is the time taken for the wave to complete one oscillation. That means it is starting from here, going down and going up, and it is coming back to its original position. There is one complete wave. What is the duration it is taking? That is considered as the time period. It is denoted by the letter capital T. Okay, you can see here wavelength, we always denoted this by lambda. Okay, next one is frequency of the wave. Frequency of the wave is defined as the number of oscillations per unit time. Number of oscillations per unit time is called frequency of wave. It is denoted by the letter V. It is denoted by the letter V. V is equal to 1 by T. What is the relation between time period and the frequency is frequency V is equal to 1 by time period T. So this is the relation between frequency of wave. Okay. Next, we are going to see the phase, how the phase is connected over here. In this wave diagram, you can see here A, B, C, D, E, F, G and H. The positions are given over here. In this, consider the 2 points A and B on the wave. A and B on the wave, if you consider, their positions as well as their behavior are same. Their positions and their behavior are the same. Therefore, this point A and point B are in the same phase that we can consider over here. But if you consider the points F and G, where is F? This is in the center here. G is in the center of the next wave, that is downwards. It is upwards, this is downwards. Even though the waves are same, but both are in different, totally opposite, behaves totally opposite, because this is the positive side of the wave, this is the negative side of the wave. Okay, so F and G are out of phase. That is what we can consider over here. Okay, thank you.